All right, let's dive in. We're about to explore the one concept that literally gives your code a brain: conditional statements. This is how we go from writing basic scripts to building programs that are actually, well, intelligent. Just think about it for a second. From the moment you get up, your brain is just this nonstop decision machine, right? It's constantly checking things and then choosing what to do next. Is it raining? Okay, grab an umbrella. Is traffic a nightmare? All right, I'll take the back roads.
And believe it or not, that's really all we're doing here. We're taking that complex, messy logic that happens in our own heads and we're translating it into code, using a really simple principle. We're teaching the computer how to think like we do.
And here's why this is so huge. Without conditionals, a program is just a dumb robot. It follows one list of instructions, step by step, no matter what. But with them, suddenly it can adapt, it can react, it becomes dynamic.
Okay, so where do we even begin? It all starts with the foundation. Before we can make any kind of decision, we have to understand the absolute core of how a computer sees the world. And in its world, every single choice, no matter how complicated, boils down to a really, really simple answer.
And that simple answer comes from something called a Boolean. It's the simplest data type you'll find with only two possible states. In Python, you got to remember, they're always capitalized: true or false. The best analogy? A light switch. It's on or it's off. There is absolutely nothing in between. Now, this one concept is the engine behind everything. I don't care how crazy your condition gets. You could be checking a user's age, their password, and their location all at once. Python's job is to slice through all that complexity and give you back one of just two words: true or false.
So how do we get that true or false? We use these things, comparison operators. You can think of them as the questions we ask Python. Hey, is this thing equal to that thing? Well, you use the double equals. Is this bigger than that? You use the greater than sign. Each one of these returns a simple Boolean answer.
All right, let's actually step inside Python's mind for a moment. When it sees the code age greater than or equal to 18, first it grabs the value of age, which in this case is 18. Then it asks itself the question from the operator: is 18 greater than or equal to 18? Well, yes, it is. So the entire expression just melts away and becomes one word: true.
And this right here, this is the mental trick that changes everything. Before you even type the word if, just stop for a second and ask yourself, what is the one thing that has to be true for my code to run? If you can answer that clearly, the code practically writes itself.
Okay, so we totally get the true-false thing now. So what do we do with it? Well, that brings us to our first tool for taking action: the basic if statement.
And what's so cool is that the syntax, the way we write it, perfectly mirrors how we think. In English, you'd say, if it's raining, then I'll take an umbrella. In Python, it's if some condition is true, then a colon, and on the next line, indented, you write the code that should run.
Here's a perfect, really simple example. Our condition is temperature greater than 37. If the value stored in that variable makes this statement true, Python will jump inside that indented block and print the message. If it's false, Python just shrugs and skips it completely, moving on to the next line of code.
Okay, everybody, lean in for this one. I'm serious. This is the single most common frustrating error that every single new Python developer makes. A single equal sign is for assignment. It's an order. It tells a variable to hold a value. It doesn't ask a question.
So let's just burn this into our brains right now. A single equal sign, equals, is an order, a command. A double equal sign, double equals, is a question. And when you're using an if statement to make a decision, you are always asking a question.
So an if statement is fantastic for the yes path. But what about the no path? What's our code supposed to do when the condition is false? Well, that brings us to the next logical step where we introduce a partner to if, the else statement.
And once again, the logic is just like plain English. If this thing is true, do path A. For literally every other possibility, or in other words, else, do path B. It gives you a default action, a fallback plan for when your main condition fails.
You know, a login system is the absolute classic example of this. If the password you typed in matches the correct one, fantastic, access granted. Else, which means if it doesn't match for any reason at all, then, sorry, access is denied. It's a clean, simple two-path decision.
And that is honestly the best way to think about else. It's your program's safety net. It's the catch-all. It's the part that says, hey, my main condition wasn't met, but don't worry, I've still got a plan. It makes sure your program always knows what to do.
All right, Now let's level up our thinking. You know, good programmers don't just plan for the obvious stuff. They think about the weird inputs, the tricky ones we call edge cases. These are values of the extremes, like 0 or maybe negative numbers. For instance, is 0 an even number? Well, our logic says 0% 2 is 0, so the condition 0 equals 0 is true. Our code works. It correctly calls it even. Thinking about these little edge cases is what really separates a beginner from a pro.
So, let's pull all this together. What have we really learned? It's way more than just if and else. We've learned a completely new way to break down problems into logical steps, the kind of steps that a computer can actually understand and act on. So let's lock in these key takeaways. Number 1, every single decision boils down to true or false. Number 2, the if keyword is your go-to tool for that true path. 3, if else gives your code a plan A and a plan B. And finally, never ever forget that double equals asks a question, and it's always smarter to think through your conditions before you start coding.
And that's it. You now have the fundamental key, the core building block for making software that can actually think and react. So I'll just leave you with this one question to think about. What's the first problem you are going to solve with this new power?